we're working on it yesterday.
Oh yeah, all right. It's in the book too.
Both ended up missing the two middle parts.
Yeah.
All right. Yeah, there's a problem. Section 11.3. Let's see. I appreciate most of the people that are graded so far have at least attempted this. In the book, it's number 45. I think it is. Yeah, I think that's the one, right? 45. I like that. So, the derivation of a hyperbola equation. You run across this step. It's number 45 and 11.3. Square roots. Now, if you remember, the idea of a hyperbola was that a point on the hyperbola, xy, the difference in the distances between these foci, right? So the difference in these two distances, so this is d1, d2, so the difference in those distances must remain a constant. You guys kind of with me? So as this distance gets bigger, this distance must also get bigger so that they remain a constant, right? So look at this. This is the equation for the distance between the point negative c0 and xy. That's d1. Minus the distance from c0 to xy. Can you guys see that? There's negative c0, right? Because there's nothing in there. There's c0. Cool, that's just applying the definition of a hyperbola's collection of points. They're all the points that there's distances from two set points foci. The difference of those are always the same. Yeah. So in the working out, so they say, okay, you work this out and you eventually get to c squared minus a squared times x squared minus a squared y squared equals c squared minus a squared. Yeah. And then they say, okay, show that. Do that. So, I mean, how would you attack this? A few of you guys have already done this, or at least tried. How would you start to attack this?
Foil.
How do you mean foil?
You bring it to the other side.
Okay, so you would bring like one of these radicals to the other side, and then you would square both sides. You could do that, sure. You can actually square it the way it is, although I highly recommend not to. Yeah, is that? I mean, that's the first step, and then really this is just a problem you can just sink your teeth into. You just attack it with very basic math. It's very basic. You just got to keep track, and that's what people kind of hate. You kind of inherently, and I don't blame you because it's a human thing. We hate trying to keep track of shit, for the most part. Some people love it. Most of us hate it. And so we hate this kind of problem because it's really just keeping track of what's there, what's not there, what's simplified. But I would highly recommend. Add that over, square both sides, and then keep going until you get here. That's all I'm going to
It did not help me.
What's the matter?
Well, there was one where they have it where you do square it, and it was like 1 is 4, then another 4a, and so I thought the third one would be 4a squared, and I was like, no.
I don't understand.
I don't mind. I don't know.
But have you tried that yet on this problem? This is the same problem as there, right?
Yeah, I already have two missing off how they have it online. So.
But have you tried that first step yet?
Yeah, I have that first. I have that.
I mean, have you tried to add that over, square both sides?
I have that part. That's it.
Alright, so you're going to have to come see me with your work. Yeah. Or get as far as you can and turn it in, and I can put some notes on there. Anything else from homework?
Same section 49.
Oh yeah. Some comets, such as Halley's Comet, traveling elliptical orbits around the sun. Other comets come through in a hyperbolic path. So of course, if you want to come back to somewhere, if you want to start somewhere and come back, what kind of path do you not want to take? Hyperbolic. Because a hyperbolic path, you will never come back, right? You want a closed path, circular, elliptical somehow. Cool. So Halley's Comet keeps coming back, right? Just enough time for Mark Twain to grow old and die. Again, talked about that before. Blah, 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 blah. Oh, so they give you a figure showing the path of a comet that's on a hyperbolic orbit. So it's not really an orbit. Blah, 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 blah. And it says, find an equation for the path, assuming that the closest the comet comes to the sun is 2 times 10 to the 9th in miles. Ooh. So they give you this picture here. Here's the sun. And then here comes the comet. Here's the comet. And this distance here is 2 times 10 to the 9th miles. Alright. And you're supposed to figure out the equation for that path. I like it. And where, what's the name? Let's see. Blah, blah, blah. The path the comet was taking before and near the solar system is at a right angle to the path it continues on after leaving. Oh, okay. Alright. Well, they tell me this is right angles. I like that. What the hell good would that do me? That's a right angle, they tell me. Those asymptotes are at right angles to each other. Does that do me any good?
I'm going to assume yes.
Something. Does help me out a little bit. What's the only shape you think when you make the box in the middle?
A circle.
What's the only so wait a minute. Triangle? No. It's like at least a rectangle. It's got 4 sides. So what's the only shape that would afford me? Because if I had a rectangle that was like this, stay with me now. As always, I have a point. If I had a rectangle like that, would this be 90 degrees here between these two? No. What's going to make it 90 is if. As if what? What's the shape then? Is it going to be a rectangle or going to be more specific? It's going to be a square. I love it. If it's going to be a square, then what's the slope?
1.
Yeah, it's 1. The slope is 1. So B over A equals 1. Okay, there's some information they gave me that I didn't realize just because they told me it was a 90-degree angle between those asymptotes. So A, or B over A, or however we're going to say it, is 1. That's good to know. That's one little thing that I know. Alright, that's nice. And what's, alright, stay with me now. What kind of an equation is this going to be? It's hyperbola, right? So when I say that, what can you tell me? You don't know shit about this except for that ratio, which means you still don't know what A and B are. But what's the equation going to look like? What's one thing that's going to happen based on how we've drawn this? Okay, I like it. It is going to be minus. That's hyperbola. But the more important thing is the hyperbola that opens a certain way, so x squared is going to be first. And what am I going to put underneath this? Let's see if we can connect these two. This is the idea of not memorizing so much, just understanding. Which letter am I going to put underneath there? Why A? Yeah, A squared. Because it's y over x, right, for the slope. The minute I've chosen that, then I've chosen what goes under x. Okay, maybe you guys are with me. I much prefer that way of doing things because, in fact, we should really call it not B and A, we should call it like X1, Y1 or something. So they're more connected. I hate A and B. They're just not connected to X and Y. Some of you guys are like, makes sense, please, but hopefully some of you guys are with me. So X squared over A squared minus Y squared over B squared equals 1. So this, what's A? Where's A on the picture? Where's A?
F1.
Be very, very specific. What? How do you? Okay, yes. So it's here. So that means that this is no A. Because you just told me. You told me, which is not the same way. If that's the vertex, that must be A. All right, cool. And then this, from here to there, is what?
A plus whatever number they give you.
Because they do tell you the sun is out of focus. Let's see. Yes, the sun is out of focus. So this is the focus here. So I'm sorry, what is that distance again? That is hilarious. Your ring told itself down. That is unacceptable. So what is this? So this is the focus. So how far is the focus away from the center? No, you're thinking parabola. It's not where there's an imaginary other piece to this. With these hyperbolic orbits, not parabolic orbit. So how far away is the focus? What letter designates how far the focus is? C. So when they tell me this, what is that really in terms of A, B, and C? C minus A equals that. Weird shit. I'm trying to give you some tools to get started with how to do this problem. So I know that C minus A must be 2 times 10 to the 9th miles. I know that B over A is 1. So also I know that B equals A, right? Alright, that's enough. I'll let you guys keep going from there. That's all I'm going to give you. It's a kind of problem that we're less and less not able to do. Some of you guys, I don't know, I think some of you guys feel like you're supposed to have seen a problem before when you look at it. No. You just start applying every damn thing you know to it. You go, okay, what do they tell me? What is this? How does this relate to what I know? You've got to go through that process. Students are more and more than like, I've never seen that. Yeah, I don't care. Yes, you have. It's hyperbola. You've seen it before. Right? It's just kind of backwards. You're trying to figure out the equation from what's there. I don't know if you could tell, but I like that problem. Alright, so enough on that one. Good luck. Anything else from homework that I can partially help you? At least I partially help you. Right? Alright. Oh, 43, 11.4. 11.4. $43.
This one was about something.
Oh, okay. Yeah, okay, I like it. So, there's if we look at it from above, this is 43 and 11.4. That looks more like, I don't know, but I'm just going to keep going. So that's supposed to be an ellipse. And they tell me the Earth is at one focus. And they tell me that it gets, what did it say, 140 miles away. And it gets 440 miles away. So I'm not giving anything away. This is what they got in the picture. Unfortunately, they did that for you. Blah, 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 blah. Oh, the height of the satellite above the Earth. All right, so let me be a little more specific. So they don't tell you this. There's the Earth sitting there. All right. Blah, 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 blah. Where'd you go? Here. Assume that the Earth is a sphere with radius 3960 miles. This is obviously not drawn to scale. Just so we can actually see what's going on. So the radius is 3960, so the diameter is twice that. So what's that? 7, 9,
I don't know.
20. I like it. 4,000 is 8,000 minus 240 is minus 8 is 7920. Or 2 times that. Okay. Alright. So what are they asking for? The equation again? Mm-hmm. Find an equation for the path of the sunlight. Okay, with the origin at the center of the Earth. Ooh, that's kind of evil. I like it though. Ooh, that's right, because this is the section where it's shifted. So here's the center of the ellipse. Here's the center. But they want you to put your coordinate system, so that's where the origin is, at the center of the Earth. I like it. You would, Jeff. So, I mean, this is nowhere near as hard as it seems. It seems pretty hard. But how far is this? Be careful. It's not drawn to scale, so be careful. Yeah, well, it'd be 7920 plus
440 plus 140.
580. Good. So it'd be 8,500. That's 8,500 miles across. And what is that in relation to terminology about an ellipse? That is the what?
Major axis.
Major axis. Kick ass. So what would like A be if we call A the thing under the major axis? It would be half of that. Kick ass. So you know what A is. Right? So A will be 4250. Yeah, just make numbers. This is not centered, right? So you're going to have to figure out what that center is. But that shouldn't be too hard. Maybe. We'll see. And again, this is not the best picture because it's not to scale. So you got to keep reminding yourself that, right? But you know what this total distance is, so you know where the center has to be. In relation to this, so you really have to figure out what this distance is here, right? So your center is going to be negative something, comma 0. Do you guys see that? Because it's behind the origin, right? You just got to figure out how far is this. Maybe. You guys are excited about this. Is there anything else I know that I can use? I mean, they don't tell me anything about this direction, do they? Right? They don't tell me a damn thing about this direction, I don't think. No. Yeah, it's too damn bad for us. But what's, for example, let me see. If I do this plus, so this is at one focus. So what is this distance here? Let me see how to say this. Now I gotta be careful. This distance is going to be what now? That's the distance from the center to the focus.
Minus 3960 minus 140.
Well, I'll let you guys figure that out. Well, what is this going to represent? And again, this is sort of like when I was asking about this guy. The sun was at a focus, so I knew what that was. You can see in it. That feels a lot like that last problem. So that's C. If I can figure that out, I'll know C. I know A. If I know C and A, you know B. Okay, I've gone too far. Some of you guys are like, no, you have not, Jeff. But yes, I have. I've gone way too far. Right? I do not think you know what too far means. No. All right. Anything else before we get back into geometric stuff? Alright, so just to remind you guys what we did last time. Let's see, for arithmetic, spoil the big sign. Let's see, I got AN. That to define a specific term. What was that then?
N divided by 2 times A1 plus AN.
Big ass. So notice that you have to figure out what this last term is. But notice something else too. You see, I have a formula for AN, don't I? So if you wanted to, you could plug that in there, simplify a little bit, and get an equation based only on what A1 is. You guys gonna understand what I'm saying? Do you have to? No. Are you interested? I don't know. Probably not. right? But I can combine these two and get an equation for the sum that's only based on what A1 is. If you want it to. I'm not. So geometric is what we're going to focus on today. We actually already came up with AN for geometric, believe it or not.
3 minus 2.
So let's look at this specific example. Let's see, you can do the chapter. Can I? Yes. We'll just look at this one we did the other day. So A1 is 2. How do you get to A2? Multiply by negative 3. How do you get to A3 from here? Well, how do you get to A3 from here? You multiply this by negative 3 again, right? So you multiply 2 times negative 3, you multiply by another negative 3. Is that cool? So how many negative 3s did I multiply this by?
2.
How many?
Oh, that one.
0. Cool. I like it. So this was 2, this is negative 6, this will be 18. So what's AN?
2 times negative 3 and minus 1 and
Kick ass. So considering this, what's AN for any geometric sequence? The 2 was really what in general? A1. So it's the first sequence element times, who remembers the letter I used for negative 3? D. Did we talk about that? No, D is common difference. R for common ratio. When you divide to figure out what you multiply by. So R to the evil n minus 1, because we don't start at 0, we start at 1. So you haven't taken any steps, but you're on the first step already. You're like, how did I do that? Oh well, you did. That's why this n minus 1 is there. So here's the freaky part. I want to figure out what Sn is. Now why do you think this is so simple when this is not going to be anywhere near simple, really? Why do you think? Because what does S mean again? The sum. And what is this sequence based on up here? Addition. So summing a bunch of additions should have been simple, and it was. In fact, right? In fact, supposedly, little 9-year-old Gauss or whatever did it so quickly. Whatever Gauss. Show off. And this one is based on multiplication, so adding a bunch of multiplications is not going to be easy, because we know they don't play well together. Right? How are you guys doing? All right? So let me write this in a very strange way. Not really, really strange. It's basically what we did here. So if I just have some arbitrary geometric sequence, what's A1? So let me say this. Here's Sn. So Sn would be A1. So what does Sn itself mean again? What does Sn mean? The sum of the whole series? Up to, partial sum up to n. So if S3 would be the sum of the first 3 elements, right? S18 million would be the sum of the first 18 million elements. S, without an n on it, just means to go to infinity, the whole damn sum. And that's what that means. I like it. Which we now know does not always equal infinity. It can actually equal very small numbers. So instead of putting A2 here, can it be a little bit better than that? What would A2 be? You could do it, what would A2 be? N is 2, so it would be A1 times R. Which makes sense, because how do I get from one sequence element to the next? I multiply by R. That's the common ratio. That's what I keep on. That's the common multiple. We could even call it an M, but we didn't. Oh well. So what's the next one?
A1R.
Oh my god. And then up to A1 times R to the N. Yes. Stay with me. I'm going to derive the formula like we have done a lot of the time. Bless you. So even if you don't fully understand the derivation, you can still use the formula, right? I'm hoping you understand the derivation. And just to remind you of we'll get there in a second. I'm trying to think about which way I want to go. Well, yeah, okay. Just to give you a little motivation as to why we do what we're about to do. Do you guys remember how to figure out how to write this as a fraction? We talked about that, right? If we didn't, you're about to see some neat shit. Does anybody remember talking about that? Did we talk about that? I talked about it in several of my classes, so I always forget which class did I not do. So the way to write that as a fraction, why do I know it's right? It can be written as a fraction. What? It's repeating, right? So any decimal that has a pattern to it can be written as a fraction because it's rational. Ratio. Rational numbers can be written as fractions. That's got to be able to be written as a fraction. So tell me, what is the answer? X. Yay. All right, good. I don't know what the hell it is. I'm going to call it X. That's awesome. Algebra comes in and says, dude, call it X. All right. Now here's the trick. And we're going to use the same trick here, believe it or not. Even though this doesn't go out to infinity, I'm going to use the same trick here. This is neat. All right, maybe. So, the sucky part is this goes to infinity. If only there was a way to cancel that part out. And the trick is you multiply the whole thing by, in this case, 100. Because what happens when I multiply by 100? What does this become? 12 forever, right? So what happens when I take the difference of these two? What's the difference? What's 100x minus x? I'll do that part. Okay. And over there it's just as easy. What's 12 point mess minus point mess? What's the point messes do? Cancel. So x is 12 over 99, which reduces to 4 over 33. Become a 33. So if you did 4 divided by 33 in your calculator, it would tell you 12, 12, 12, 12 as far as it could. Let me let you soak that in. You can do that with any repeating decimal. Bless you. How are we doing? Now, here's the weird part for you. How do I use that idea here? I don't know. All right, you ready? Here we go. Here's the idea. If you multiply by r, so what's r times Sn? What do you get over here? A1 times r plus A1 times r squared plus, let me see if you guys can handle this. What's right before this? Just so you guys can really see where all this is coming from. What's right before this? A1 times r to the n minus 1. Cool. So when I multiply that by r, what do I get? You can do it. Really want everybody with me with the idea of what I'm doing. I'm taking this whole thing and multiplying by r, right? That's all I'm doing right now. So this currently has n minus 1 r's. If I multiply by an r, I'm going to lift it up to have how many r's now? N. If I multiply by r, how many r's will it have? One more than it did, right? So if it has n minus 1 now, after multiplying by r, that term is going to have n. R is n. What's that term going to have? Cool. Now, how are we doing? Alright, now if I take the difference between these two, make sure I do this right away. So if I take Sn minus r times Sn, if I take the difference between these, what happens? A1 is fine, right? These do what? Cancel, 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 cancel. So you're left with, careful, I'm taking the difference. Minus A1 r to the n plus 1. Alright, let me let that soak in. Oh, I see what I did. Let me see if I can salvage this. You guys kind of with that? Alright, you're going to love this. I did make one little mistake. This is totally my fault. It's because I should have went out only to this far on this. I went one step too far. Is that cool? If I do the nth element, what's the nth element? A1 times r to the n minus 1. Do you see how I went one too many out? I hate when I make a mistake, but I just did. Oh well. So that's proof I'm human, so I don't have to show you blue. So that was too far from this, my bad. So that means that wouldn't be there, so that means that would just be that. Either you get that or you don't. That was my bad. Alright. So now watch, it's kind of cool. This is neat. I'm trying to figure out what Sn is. This sucks. I don't want to do this. If I want to figure out what S800 is, I don't want to do the first one plus the next one. I'd rather find a shortcut like Gauss did, right? So here we go. Now watch. What can I do with this? Take an Sn out, so I'm left with. And over here I'm going to take an A1 out, just to kind of make that side feel like it's doing something. And then I can divide by 1 minus r. So Sn equals A1, become an A1. Times 1 minus r to the n, divided by 1 minus r. Is that a nice formula? No. But did we expect it to not be nice? Of course we did. We're adding a bunch of multiplications. They don't play well together. I'm not going to get a very nice equation. Let's immediately do a concrete example so you can see what the hell this means. So now we have 1, 2, 3, 4 equations. 2 for arithmetic and 2 very similar for geometric. So let's see, let's do this little dude we keep playing around with. 2, negative 6, 18, negative 54. So we just go up to there. What is S4? Just looking at it. What is it? What am I asking you to do? What am I asking you to do? What's S4 mean? Add up the first 4 terms. Do you see the first 4 terms? Yes, add them up. What do you get? Yeah, so you get negative 60 plus 20, so minus 40. Cool. I like it. How are we doing so far? I'm going to show you a concrete example. Whenever I do this, students start to forget why we need a formula. If I say S29, do I really want to do this? No. So I'm using 4 so I can compare. Does the formula give me the same damn answer I get just doing it the normal way? If it doesn't, throw the damn formula out and start over, right? So it's all hope works. So the formula is A1 times 1 minus r to the n over 1 minus r. So if I want the fourth one, A1 is 2. 1 minus in r, of course, was negative 3. To the 4th power, I like it. All over 1 minus negative 3 to gas. Well, just plug and chug now. All the hard work was this. Now it's just plug and chug. So I get 2 times, what's negative 3 to the 4th power?
81.
81. So I get twice 1 minus 81 is negative 80. And then 1 plus 3 is 4. That's awesome. So I get half of negative 80 is negative 40. Gas. Yay. It's the same answer. Of course it's the same answer. They both do the same thing. So now we have a shortcut. If I ask you for S29, you just plug and chug into this equation. One little advantage that this has over the Sn for arithmetic is it only depends on the first one and the repeated multiple, right? I don't have to know what An is to figure out what Sn is. Yes, ma'am?
Can you explain real quick how to find R?
Oh, sure. All right. So let's look at let's look at 2 more examples at least. Figure out what R is in each case. So what about what you got, Jeff? I like that one. That's cool. What is R here?
1/3.
Yeah, it won't be negative, right? Why is it not negative? Because it's staying positive. It's not changing signs. So R will only be negative if my sequence is alternating signs. Right? In fact, we call that an alternating sequence. If it's negative, positive, negative, positive. I'm not really multiplying, am I? I'm actually dividing. So how you always find it is actually related to why that's an R. Why was that an R? Common ratio. What's 81 divided by 243 or better? 9 divided by 27? 1/3. So R is 1/3. R is the common ratio between the sequence elements. If I take 1 divided by the one before it, I'll figure what R is. Remember Fibonacci? Real quick little side note. I know I spoke the hell out of Fibonacci. But remember, if you take one element, so I'm going to call it Fn. If you do this, it's going to equal 1.618. You know. Remember that, the golden ratio? So Fibonacci eventually becomes geometric-like. There's a lot of sequences that don't multiply by the same thing always, but what they're multiplying by itself is approaching a value. So they're geometric-like. And again, if you get to 280, depending on how your teacher teaches things, this should sound very familiar at some point. And you're going to be like, I'm not going to remember today, Jeff. Oh well, alright, that's right. So you always do that. If you know it's not arithmetic, you try geometric next. And if you know it's not geometric, you try something like Fibonacci, something weird like that. So what if I had this here? I don't know, Jeff. What you got? I don't know, Jeff. Sure, we can do that. I'll be nice here. I'll keep it. What are you trying to say? No, Jeff. No, I'm being stupid. That's too bad. You guys just call me. There it is. Maybe you guys can see this without actually having to set up the ratio. What do I keep multiplying by? What did I multiply on the top every time? Negative 2. So R is negative 2 over 5. Kick ass, right? So you can either take one element divided by the one before, and just to double check and make sure, do another pair, just make sure that that actually is true. It holds forever, right? If that would have been an 8, oh shit, it's not the right thing, right? You could do that, or you could just kind of look at it, especially when they're fractions, you can kind of tell what did the top do, what did the bottom do, and then make that ratio. That's what R is going to be. Alright, maybe you guys see that. Because that's right. If you can't figure out what R is, you're screwed. Everything depends on R. So if I ask you in this problem, what's A11? It's going to be gross. It's going to be gross. A1 times R to the n minus 1. So it's negative 18 over 5 times, let's see, what is it going to be? 964? Is that what 2 to the 10th is? No, that's not right, Jeff. What am I doing? 1024. 5 to the 10th, yeah, have fun with that. What's 5 to the 10th? I don't know. Scheisse. That's crazy. You guys can do it? You got calculators? What's 5 to the 10th power? What's your calculator say?
9,765,000.
Wait. 9,
76,
7, 6,
5, 6,
5, 6,
2, 5.
2, 5? 9, 7, 6, 5, 6, 2, 5? 9765625.
Yeah.
Alright, and then you just multiply by 18 on the top and 5 on the bottom just to finish that out. Is that cool? And of course, this is to a 10th power, so this negative became a positive there. Be careful about that. So this is actually going to come out negative at the end. So whatever 18 times that is, and whatever 5 times that is, that's what that is. Right? Try to stay away from decimals. I'm not going to give you one that's going to get crazy bigger than that. You with me? But if you write the decimal out, you're automatically wrong. Because you have to stop somewhere. And the decimal doesn't stop. It keeps going. Right? So I'd much rather you give me the right answer than some wrong approximation. And of course, if I ask you what, the S is going to be even worse. But I just got to plug and chug into the formula. There, right? So it would be negative 18 fifths times 1 minus negative 2 fifths to the whatever, over 1 minus negative 2 fifths. Right, you just got to plug and chug now, right? That's all I got to do. Alright, cool. Just to show you that not every sequence has got to be numeric. I love this one. I give you a clue. It's not numeric, but it sort of still is. Which element is this one? Which one is this one? This is a 1, and this is a 2, this is a 3, a 4, a 5, a 6. So what's the next two? S, E. Alright, good. 7, and 8. And this is one example of how, a sequence could be visual, right? So I could have a sequence like this. What you got, Jeff? What would happen in that sequence? What's the main idea of that sequence?
Number of sides increases by 1.
Exactly. So then you just got to draw me 6-sided figure, right? That's a 5-sided figure. So you can draw me 1, 2, 3, 4, 5, 6. And then it's gone. But don't go into the octagon. So then 1, 2, 3, 4, 5, 6, 7. Nobody said it had to be nice, right? Is that cool? Alright, so I just want to show you, and of course, even for numerical sequences, now watch this, this kind of gets interesting. You guys are all like, yeah, whatever. Yeah, cool. I like it. So it's a very simple example of a multi-level sequence. You add 2, then subtract 3. You add 2, then subtract 3. You add 2, then subtract 3. Do you guys see what I'm saying? So, you can have sequences that have changing definitions within itself, right? Now, I'm not going to attack you with something insane, because if I give you something insane, it just depends if you're lucky or not, if it happens to click or not, and then that could totally depend on how your test goes. I'm going to try not to do the two. I'm going to stick to mostly the arithmetic and geometric, but please understand, I will give you something sort of like this.
Cruel.
Huh? Cruel? You should know that by now.
How would you write the general form for something like the bottom one?
Well, for this?
Yeah.
So one way you could do it is all the odd terms, right, follow one definition. So I'd say a sub 2n minus 1. 2n minus 1 is a general way to write an odd number. It's 1 off from a multiple of 2. That's what the definition of odd numbers are, right? So I'd say a sub 2n minus 1. Now this is where things get interesting.
A1 minus 6 minus 1 is 5.
Now you got to base it off of this guy, right? So a sub 2n minus 1. So this is the first one, this is the third one, this is the fifth one. Alright, I'll let you guys. And then a sub 2n, you can define it off of that. But that's how you can do it. Right? I'll let you guys figure that out if you want to. I'm not going to give you one like that, though. They get a little freaky. I thought you were going to start to ask me about this. There's no real way to write AN for that except in words. Right? And the same thing there. Okay. Maybe. Okay. Let's see. Let me make sure I didn't forget anybody. Do they give you... They do. Kick ass. All right. One last thing we'll do, and then we'll call it a day. I don't know if you guys remember, remember this example I gave you? And this is the example I give my Math 280 students. All right, when I ask them if you add a bunch of numbers that go forever, can it ever equal a finite number? They say, no way, that's crazy. I give them this example. We looked at this example before. So will that converge? Will that actually become something not infinite? Of course it will. It actually will become what? 0.1, 1, 1, blah, 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 which is 1/9. So we looked at that before. You guys kind of with me? So what made sense? Remember I tried to point this out before. What made sense? All the terms have to go to 0. And if I have, what kind of sequence is this? Do I keep adding something to get from here to here? Did I add something to go from here to here to here? Do I add the same amount? No, I divided by something, right? I divided by what? So I multiplied by 1/10. So R is 1/10. I like it. But what would this represent? Well, what is this in symbols? Oh, you guys just love those. Huh? Oh, yes. So that's S. Because what's Sn? What's S80, S800? That only adds up to the 80th or 800th term. What's the only way I can get to the full 1/9 is if I add up all the freaking terms to infinity. So in a way, this is S infinity. Notice I didn't write that because it actually is physically painful for me. You never do that. You can't put infinity in somewhere because you can't get infinity to put it somewhere. So just don't do it. Alright, stay with me now. What I want to show you, we know that if we stop somewhere, this is this guy. But what if we don't stop somewhere? Right? I want to develop a... what am I trying to say? A formula for the full sum. Don't stop somewhere, not the partial sum, the full sum. So think about this. What has to be true about R so it does what we know has to happen? These have to go to, the limit has to be 0. Does that make sense? Because if the limit was 1, that means eventually it gets close to 1. And if I add 1 forever, am I going to get something that's not infinity? No, I'm going to get infinity. If I add 1 forever, 1 plus 1 is 2 plus 1 is 2 plus 1 is 4. Oh shit. So the limit of these has to be 0. Stay with me now. What's got to be true about R then? What's got to be true about R? This is not the only R that would work. How am I going to make sure that my sequence elements are just always decreasing? They're always getting smaller. R itself has to be less than 1. Because how would I make my sequence elements stay the same? R would equal... How would I make them stay the same? R would be 1. If I keep multiplying by 1, what happens? I stay in the same place. Right? And if I add, so if I start at 2 and then multiply by 1, and then multiply by 1, and then multiply by 1, what happens when I add all these together? Infinity. But if I start at 2 and then multiply by 0.9, and then multiply by 0.9, and then multiply by 0.9, that'll actually go somewhere. That'll actually be less than infinity. So the way I explain it to my calc students is, I need a sequence of terms so that when I sum them, they get out of their own way. They don't overlap too much, so they don't go to infinity. They actually see how this one is perfect. It gets out of its own way by going to the next decimal place, going to the next decimal place, going to the next decimal place. So it's never overlapping. It's never getting really big. It's not. It's just filling in all these decimal places. Maybe. And by the way, this lecture is going a little beyond what you have to worry about the homework. That's too bad for you. I just want to give you the whole picture. So what we do, if I assume that, and I'm going to make the absolute value of r because r could be negative. If that's less than 1, then tell me, what's the limit as n goes to infinity of r to the n? Oh, that's so loaded. I love it. Yes, it's got to be 0. If r is less than 1, and I keep multiplying, what's 0.9 times 0.9? You can do it. What's 9 times 9? What's 0.9 times 0.9? 0.81 times 0.9. 0.72. See how it keeps getting smaller and smaller? 0.99 times 0.99 is 0.98 something, I think. I don't know. Right? It's going to get smaller and smaller. When you multiply a number that's less than 1 by itself, it gets smaller. So the limit of this will be 0. Stay with me now. Stay with me now. So if I want to start here, I want to start right here. Yes, Jeff, you said that several times. So and I want to make this S, which really means let n go to infinity. So I want to take the limit as n goes to infinity of this. And what we just say happens to this dude? 0. So I get a1 over 1 minus r. That's awesomeness. That's so beautiful. You're like, whatever, man. But let me show you. Let's see if we get that 1/9. Yeah? Let's see if we get it. So if for this sequence here, this series, I have r is 1/10. I have a1 is 1/10. Is that cool? a1 is 1/10. r is 1/10. So then how do I use this formula? It'll be a1 over 1 minus r. Help me out. How do I do this? I forget. There's 2 ways. What I always do is multiply top and bottom by 10 to kill the inner fractions, right? It's not like your inner child. Don't kill your inner child, but you want to kill your inner fractions. Right? So if I multiply by 10 on the top and bottom, I'll get 1 over 10 minus 1, which is 1 over 9. Holy shit. So I love this example. This is why I start with this example when I teach my Calc 2 students who do a lot more weird shit with this than you ever will in this class. So if you go to the 280, I start here because it makes the most connections to me with other ideas. It gives you the idea of this. It gives you the idea of this. It gives you all these kind of ideas. I love it because they're weird ideas. So all you guys have to be responsible for is this equation now. So if I want to know what the full sum of something is, S infinity if you want to call it that, that's the little formula, dude, that you would use. But it only works if your r is less than 1. If r is bigger than 1, it's not going to converge. It's going to go to infinity. If r was 2, I got 1, 2, 4, 8. When I add those up forever, I'm going to go to infinity. There's no other way.
So in a case like that, we can just put those to infinity?
Yes, I love it. So if I say what's S for 2, 4, 8, what's S? You would say it goes to infinity. Kick ass.
The ratio of that's more than 1, right? It's not between negative 1 and
Yeah, see, this will be R with here would be what? 2. Bigger than 1, divergent. It diverges, right? Not the dumbass movie. I don't care. I don't want to see it. Right? Hunger Games, whatever. The twilighting of everything. Anyway, so we got warm bodies, the twilighting of zombies. Come on, stop it. Stop it. Sparkling. Sorry. That's the last equation you're responsible for, is this little dude here. Cool. I like it. That's all I got for today. Which is nice. So we're only up through 12.3. That's it. Tomorrow I have the answer key for the practice final. I gave that out yesterday.
So we don't have to do 12.4 anymore?
Who what?
So we don't have to do
No, 12.5, yeah, no.
So, wait, 12.4.
12.4 was never part of the homework.
For 10.8, are you want to just figure out as extra credit, or did you find the more than
Do it again?
you know how you said 10.8 is extra credit? Do you want to have it or after
Which, 10.8 was extra credit? Oh, have I not put it online yet, is that what you're saying? Could you just give me your mind? Shoot me a message? Yeah. Thank you.
Yeah, they're going to do.
Well, you're already saying what's
Yeah, it was,
Well, I'm sorry that you guys want
it was only 4 questions. So each one was worth 20 something points. Yeah. So I mean, that one worth like 6 points. Oh, I'm just trying to tell you that's how you know it's going to be an ellipse, because the coefficients are different. You know, so you had the 1 plus. Yeah.
Alright. I do not.
I was just looking for with that feeling. I took it out of here. I was going to start making answers. You can email me and I can send it to you.
Okay, yeah.
Yeah, okay.
Yeah, that is the correction.
Yes.